Okay, the only thing is we want 1024, 60 hertz. All right. There we go. Right. So, I guess most of you heard Dan's talk yesterday. This is about the same project. It's about Smalltalk-78. And the other people directly involved were Ted Kaehler, Yoshiki, who's over there, Ted is over there, and Alan Kay. So he used this system to make the presentation as in the video that Dan showed yesterday. And I always like to use our Smalltalk systems to give the presentation. So I would really encourage others to do it. Like yesterday we heard someone talking about implementing a fancy new kind of text. And we didn't see it, there wasn't even a screenshot, I think. So using your new text to give a demo would be really cool in my opinion. So we are back in 1977. Pixels were expensive. We have 1 bit per pixel, that's all you get. But if you squint a little to make a low pass filter, you actually can see the grayscale here. So it starts, and I guess in the back row it looks like a grayscale image. It's actually black and white pixels. If you're sitting here, you see each pixel. So that's the note-taker machine. It was about this size, and I don't know, 10 pounds, maybe a bit more.
More.
Yeah, more. But you could take it on a plane, and was one of the first portable computers. And the whole operating system was Smalltalk. So it had actually 3 CPUs inside. One was the processing, the central processor, and there was an Ethernet chip, and one more. I don't know. And then actually made Bitlit run on the network processor, so it could run in parallel to the code. So get some kind of parallel processing to speed it up. And 256K bytes of RAM, that's not much. The disk was much larger either. So you could load an image, but they didn't ever get to the point to save an image, so that's something I put in. So they were adjusting the image on the Alto, and then moving it over to the note taker. The software, VM, 6 kbytes assembled code, so that's the result. The source code is a bit larger. The object table and object space, that's 2 files we got. Someone found on the Apple, the Xerox disks. Yeah? So when Park, yeah, so that's one instance of this surviving. 10 of the note takers wrote those. And it's not large, but it's pretty much Smalltalk-76. So Dan talked about this yesterday, so I won't go into the details. The language is exactly Smalltalk-76. The runtime environment is a little bit different, but you all know Smalltalk-80, right? That's what we are using, or descendants of that. So in 76 and 78, there were no booleans, there were no blocks, no meta classes. But there was a cool thing, you could code your own assignments, and I'm going to show you a little bit of that. Next project. Assignment. Is that somewhat readable? So because the original font was this, so this is Cream 10 hand pixel by Alan Kay. It took me a while to read it. Now I can actually read it. It takes you 2 days to adjust it and recognize it. So that's how it actually looked. And there was no larger font, so we put in Palatino and Helvetica. There were more fonts on Smalltalk-76, but not in the note-taker image because it was small. So I had to go in and use the font editor. There's a font editor in the system, so I went in and added these glyphs here. Like this became the hash mark for arrays later. So it's just a quote symbol, and then we have here. So this is actually a method. It's called at put. But it's a binary selector, and you can have as a second part, as the last component of your selector, you can have an assignment arrow, which is the underscore ASCII code, which is because it uses ASCII 65, which still had an arrow in it, and they changed it later in, I don't know, in the 70s. As you would expect, if I print this, it's 42. And the same thing works with keyword messages. So you can have a stream next. So if you have a stream, you can have stream next, which would get you the next character. But you can also say stream next gets, I don't know, 42 is a nice number. And that's a statement, and you could also say, okay, stream next 5 gets 42, and the selector for that would be this here, right? So but it must be the last argument, the last part of the selector, because a very cool thing is it could be 42 raised to, I don't know, 2. And the parser recognizes that assignment error, so you don't have two parents around it. So I thought that was very cool. You can stop me at any time and ask questions. Conditionals. There were no booleans. So true, what's the class of true? Any guess? It's just an object, it's just a singleton. So, well, singleton, it's just one instance, one specific. It's is there as oop? What's it called? Yeah, so it happens to be the third oop. Nil is first. Nil is 0.
True
so
as object. True as object.
As oop. No, I think that might not work. So nil is 0, false is 1, and true is 2. And it's actually the same in Squeak, because this image has been transformed and transformed and transformed, but the objects have never changed their order in memory. So that's why in Squeak, still the very first object in the object memory is nil. I think that's very cool. So conditionals. Well, you have macros, but in the VM, there's only one conditional bytecode. It's jump if not false. So you can actually put anything here. You can put hi, Isak here, and it will still print 42. So the VM just looks for the oop number 1. If it's 1, it doesn't, no, it takes the jump. On anything else, it goes there. And there's also no else case. So what happens if this is a method, my method, oops, method. So method syntax looks, okay, that's a text bug there, ignore that. Oh, it's gone, okay. Yeah, there are still bugs. We're fixing 30-year-old bugs. Because that system actually didn't get used on the node taker much, and they took the image and fixed all the bugs, and that became Smalltalk-78, but we still see these old bugs. So you have the brackets around the method body, and what happens is if it does not take the jump here, so if it's false, or you could say if 3 is not, oops, is not 5, no, if 3 is not 3, then it would jump over that part and to the end of the surrounding block. And so if this is just a return here, then it would actually jump out of the method, right? So I thought that was interesting.
That's not really a block, right?
It's not even a block yet. So the brackets are not significant, and that's the next thing I'm going to talk about. So this is how you declare local variables. It's just a bar, and so in a workspace, whereas in a...
It has to come first, or you can declare it at any moment?
No, it has to come first. Here, okay, so it's probably obvious what it does, right? So it's a for loop. But the way it does it is interesting. Because, as I said, so these square brackets do not have semantic meaning, they're just syntactic. The actual deferred execution is introduced by these open colons. So you have these colons which are hollow, and this means this is deferred, the I there. I could write it like this, but if it's just a simple expression, you don't have to write these brackets there. Or I could write it like that, it makes no difference. And then there's another argument here. And so what happens is that this is compiled. I should maybe show you an example of that. So let's open.
But there is no any assignment to buy.
Say again.
But there is, because colon means effectively make a block of I.
Yeah, that's what that is. So in here we have array, and in array so array is the yeah.
Oh, there it is.
Oh yeah, here's the output. Yeah, right. So it's dispatching to something, or all set to something. Yeah. So this is how you would use that thing. It's all I such that I is larger than 5, for example. And the way it's implemented is, okay, maybe we should rename this. So the note taker did not have space for the source code, so everything is decompiled. And if you read the paper, we talk a little bit about how we got some of the source code back from Smalltalk-76. But since you can read it, I don't have to talk about it. So all I such that condition. Yeah. It's the same command J key binding that's still in Squeak for replacing all. So I like that. It's old, but kind of lovely. So all I such that condition. So both of these are deferred blocks. They're compiled as a remote code, and you can call value gets on a remote code. So I is this remote code, and the value gets primitive stores into that variable. It has to be a single variable, and that gets assigned in the calling method. So you're actually assigning into whatever that variable is called in the temp frame of the calling method. And then you have the eval, which just jumps to that remote code and executes it, and then it jumps back. Yeah. So that is very cool. Actually, if I do it like this, you could actually read it. I'm sorry, forgot. Okay. That looks weird. Did I say we have bugs? Restore display. No. Okay.
Don't bother.
Okay. Good. How much time do I have? 10 minutes or so? Yeah. So what we could do, yeah. So in here you could say we have an I and we have an array. So array 1, 2, 3, 4, 5, 6. That's probably an interval syntax, but bear with me. All I such that not such such that I is larger, no, I is larger than 3, or 2, yeah. And let's print that, and it works. And let's,
And then print I.
hmm?
And then print I.
Print I.
You
Oops,
mean
I
period.
need to add the,
Yeah.
yeah. Okay. So that's the debugger. We could actually go and debug that just to show you it works. It's all in there.
Yeah.
See, so it's cool. So print I and then print I and so X6. Right. What I was going to do is, so do you maybe want to see the bytecode for that? Anyone?
Yes.
Yes. Okay. So let's switch to am I in 1280? No. Oh, it's the built-in display. How do you go get out here?
Okay, we go to
Yes,
them.
we do. Yes,
Oh, there's the
the button. Because you have two screens, so we define.
that one.
Get
That's the built-in one. That's this one. But this is not 1280. Pretty sure.
Better be phone.
Ah, that's 1280. Okay. So we are actually running inside the library kernel. Okay, come on. So to get out of the full screen mode, I need to drag that to the side. Full screen note taker. Okay, so we see our interface.
Behind the curtain.
Hmm?
Behind the curtain.
Yes. Okay, and I can enable a breakpoint. This breakpoint here is break on do it. Yes. Okay. So when I do it, which creates a new method. So I'm in there, and this here is the. So we see our stack. Then talked a little bit about how this is a linear stack. So our stack right now has 2004 elements, which is the active process. So it's an object where you have the min size, the max use, the top, which is counted from the end. So it's 161. 2000 minus 161 is, I don't know, 80,
Yeah.
90, right? So more or less. Is that true? Close. So the actual value inside here, so that's the current compiled method. All such that is in there, the remote code is in there. So you have this VM level debugger, and you can see here how the argument is pushed by this method, and it becomes the argument for the stack frame path. So that's the index here, and that's the modern way of having overlapping stack frames, because the stack of the calling method becomes the top of the frame of the new method. That's what Dan came up with in 77, right? So that's a nice way. And if I turn this off, then I just see the current stack frame here. And what happens when I step through it? There's my step button here. So I step through this. It's pushing this context, which is actually the process. So it's the whole stack. It's sending remote copy to it, which creates a remote code thing, which just has the frame offset and the starting PC. So the frame offset is, again, counted from the top. It's counted from the top so you can grow the object without having to adjust the stack frames. Yeah, so you can make your 2000 stack into a 4000 stack, and the offsets will still be right because they're counted from the end. And then it jumps over the actual code step. So it jumps to 16, then again, so that was for the I. Then this is for the I larger than 3. Then it jumps to the end. It pushes the vector itself, so now the vector is on top here. vector, and the vector has a 1, a 2, a 3, a 4, a 5, and a 6 in it. And I'm writing the 0, that's the VM index, so the VM would look for it at index 0, but Smalltalk is at 1, yeah, so that's the 2 items there. And then it sends the all such that, so I'm stepping into that, and here we see what it's going to do. Stepping in, it sends push, sends self length is 6, because it's primitive. Species new, no, let's get out of that. Return. Okay, that's the vector class. New, I'm gonna jump over this. So new, it sends as stream, and all these things. So you can sense plus over larger. So yeah. And then we have this jump defaults, which is this single bytecode that actually does conditional execution. That button. And then it's pushing temp3, which is over here. Temp3 is here. It's pushing the stream. So, yeah. And, yeah. Okay, any questions? No, good. So we can just press, I'll disable this, press run. Okay, that's how deferred execution works. And one problem with that is that you cannot actually take the block and return it up the chain or even return it down the chain because there is no block object. It's just a remote code object which is inside this method. And so when you want to pass execution down the chain, at all levels you would have to add these special colons. Next project, what else? Oh, class methods. Class methods are interesting because there are no meta classes. And one of the reasons, or maybe the reason to have meta classes was having class side methods, right? Yeah. So there's a trick because, well, all classes are instance of class. And so how could I have a class in it? So they can have instance variables, right? And they can have class variables. No, they have class variables because it's just an object. How could I initialize a class variable if there is no specific method for that? So there's a trick. We can have a class init method in window. On the instance side, there is only the instance side. But how does this work here? It does work, but window, the class of window is class, obviously, right? So it does work, and the trick is, well,
is there a window class init method?
Exact. Well, this is the window class init method.
No, window no space class init method.
Window no space. That would be too tricky even by that.
Oh.
That's an Elliottism, I would say.
It's a swizzle.
No. So what actually happens if you go to class? Why can I? Okay, because I changed the method. Kernel classes. Okay, class does have a class init method which dispatches to a new instance.
Okay.
And the same thing happens for like current and there's a couple. So there's default and there's init. So init does a self new init, and then there's also a default, I think, which so it's the same patterns.
But how do you access the class instance variable?
How do you sense this new then?
Yeah. How does the new work?
How does new work? You cannot ever overwrite new.
Right.
There's just one new in class, and that's what gets used. It's a primitive, I guess.
How to get different, Oh,
If you send new to class window, you get a window instance. If you send new to class something, you get a something instance.
And like this default or init, these methods you can override, so that's a convention.
Yeah, that's, you can override the other method, you
So
cannot
where
really
is the
override
method
it.
you define here?
Here, that's how you call a primitive. So new is a primitive.
User.
Croak. Croak is just do an error. So if I can execute it, that's user croak. A primitive has failed. So this is a primitive fail. At some point it got renamed, I don't know. I like croak.
You guys got all kind of, oh, we're going to be seen by the outside world, didn't you? You wore a suit and tie.
So croak is in Rails object, right? So so you can actually see the Boolean messages here in object because they are just objects, right? So and is self, and there's the end with the open colons and the end with the make it larger maybe.
But you said that there are class instance variables, so how from the class init method do you access the class instance variables?
Class variables.
Oh, just class variables?
Yeah, they're
Ah,
just
no
class
class instance
variables.
variables.
Yeah,
Sorry.
yeah, no instance. Yeah.
That's right.
And they're available from
Yeah.
here. And that's why they are class variables. Because they came
That's the
first.
history, yeah.
Yeah. So in here, so in the class you have an accessor add and add put, and that just dispatches to the class for us, which is a dictionary, I guess. Yeah. And that's pretty much my presentation. Maybe we've got 5 minutes for a question, so I try to make it small.
I want you to show the 2 bytecode, 1 bytecode hack.
Yeah.
Ooh, that's bad. Let's see, where did we see that? In the for loop, right?
And tell your story, right? Because Dan didn't actually let you in on it, and you butted your head against it for quite a while.
That's true. So I was implementing this with Dan, then got the first snapshot decoded and figured out where the headers is and where the actual body of the method is. So he did that in the lively kernel, and then I went in and started on the interpreter by taking my Squeak.js virtual machine, which is a JavaScript Squeak VM. I'm going to talk about it at 2 o'clock today. And I stripped it down basically, so even though Squeak VMs are pretty simple, this is even simpler. So I could rip out 80% of bitlet because whenever I check the depth, is the depth 32, is the depth something, or do something with depth, it was just a constant, it's 1, and so all the conditionals went away. It was much simpler. And let's see. Did we have that in the assignment here? Yeah, maybe this. So, a for loop. I did have a for loop somewhere. Where was it?
Yes, in the
deferred
Like,
execution.
Yeah, that's it.
in here, yeah. And it was I replaced it, right? So, let's just load the image again. Go to next project. Might have been simpler to type it. Oops. Okay, there we go.
Yeah.
And then I need to enable my breakpoint on execution. Let's see. Okay. So now we're in here. So the for loop. Do we see the source code over there? Yeah. So it's pushing a constant 1 and assigning it to j. Oops. Okay, I pressed over. That goes. It's pushing the constant. It's pushing another constant, pushing constant 1. Now it's sending +1 step. It's storing it into that. It's pushing that. So that's where it's testing if it has to jump, and then it jumps. It falls to 25, but not yet. So it can do this here. So it's multiplying. Then it jumps back to 10. And there is no 10. What the heck? My code is buggy. right? So that's when I was still figuring out, it's always +1, -1, right? So is the jump offset stored with taking the bytecode itself into account or not? So I added a +1 and then it worked for a while, but then it crashed again. And I bumped my head against that for a day or so until I asked Dan. And he said, no, that's actually correct. So the thing is, this is a 2-byte bytecode, the number 9, which is a store into arg or temp0. This is actually a prefix bytecode, so 10 is return or get temp0. And this is a modifier to make it store. So what actually happens when you jump, so I'll do the jump, it jumps in the middle of that bytecode, which does not store, but pushes the value onto the stack. And so I had to adjust my decompiler, so if my current PC actually points to some different thing, it will have to decompile it differently. So that's why you only see it now. I thought that was a very cool hack. Yeah, good one, Elliot. Anything else? We have Dan here, so ask him. We discovered what you described as skeletons in the closet or something? Yeah, but I can't remember right now. No. But let me say this, developing in a virtual machine inside a high-level language is fun.
Oh, yeah.
And in my opinion, even more than in Slang. So Slang with the simulator is good. It's better than C and GDB. But in here, because I can actually use the Lively tools. Lively kernel is pretty much just a JavaScript environment for developing a Smalltalk-like environment for JavaScript. So I can open an inspector here. So Shift-I, so that's my interpreter. It does have the active process, the base pointer, which is the stack pointer, various other things here. My last tick was this, and I can just go in there, then there's a new object. My PC is 10 at the moment over here. And I have all these special objects. I can go in here and see, okay, these are the special objects, and these are really just, that's how my objects are represented. So this here is a byte array. So I see it has a couple of bytes, just one apparently. Then all the objects are linked, so it has a next object link, it has an OOP, and it has a pointer to the class, and that's it. But it's a real JavaScript object. I'm going to talk about the details of, for example, the GC more in my Squeak.js talk, using the same GC. We also got rid of the OOPs, so the OOPs are only for information right now here, and for identifying objects in a snapshot. They're not used at runtime, you use a direct pointer model. So it's one JavaScript object pointing to another JavaScript object, and we don't have an object table. So the OOPs are just used for identity hash. And nothing in the image made use of converting from an OOP to an object, so that's fine. Yeah.
So, but you're right, but you can actually construct proxy objects for objects in the simulated system, right?
Yeah.
So you can inspect them, and I just haven't bothered to go that way because they weren't there in the first place. So there's a well-developed print-to framework, right? So that there was less pressure to produce inspectors, but it's easy, right? So you know, and in fact in the Spur Bootstrap, that's exactly how you go about transforming a method in one bytecode set into a method in another bytecode set.
Okay.
Is that you construct a proxy object for that looks like a compiled method, and then you disassemble it with a bytecode assembler, reassemble it. But what's more interesting is when you produce a proxy for going the other way. So you produce a proxy object around an object in your image, which presents that object to the simulator code as if it was in slang. So that's how you can test the JIT compiler on any method in your image, right? Is that you wrap it with a proxy that then behaves as if it was actually just the raw bits in the image, and then you can compile it to machine code and see what comes out.
About interesting things. So yeah, doing high-level VM development, high-level language development is fun.
I just saw the string users Bert ST78.
Yeah, why is that still in there? I didn't rename it. Yeah. So that's an artifact of the Lively module system, because I developed that in my personal space. So it's just a namespace.
One of the nice things about you're doing it in this environment, and Bert did a great job with this, is one of the things that we didn't have, of course, is the file system that we were running with at that time. And in the process of not more than about a day, Bert made it so that you could save files out over the internet and read them in, which is really nice.
Yeah. So for example, the way I constructed the images, the pictures in here. Well, I put that in for Alan, of course, but you can basically just take an image. Let's see, pictures. Bird. Okay, that's an image. And you drop it in here, and then I made a little JavaScript interface where you can maybe pump up the contrast a little bit, and so Dan said I implemented it in Smalltalk-78 and not quite corrected. So this is JavaScript, but I could have done it in Smalltalk-78, and the algorithm was available at that time because they had to do with black and white pixels. There's also another method for dithering, which is auto-dither, which just doesn't look as nice.
Yeah.
So that's what you may be knowing as dithering, and this is called error diffusion. It's the Floyd-Steinberg algorithm. Yeah, it's very simple. Yeah, and then when I save this, I say, okay, so it gets uploaded, and there's a transcript here. So it gets uploaded to, oops, I'm actually on the web server. Okay, I thought it was going to my local machine. Anyway, so it's up there now. And so when you open the form, okay, then of course, so now I'm on my local server. So there's another Bert form. Oh, yeah. This one's interesting too. It's an image Alan drew 35 years ago.
Yeah, it's in my Smalltalk-76 paper.
Yeah, so using this painting tool here, which is not very fancy, but nice. Also, you can actually try this yourself, and the URL is, I think I made a tiny URL. Tiny URL, did I? Smalltalk. No, that was all taken, I don't know. Okay, just used it the long one. So probably if you Google for Smalltalk-78 and Bert, you will find it. So that's the live web page. It takes a while, but it runs. And this does not have my presentation image, but you get an updated image. The image we actually got was this one. It looks a little bit different. It's just the last snapshot, or one of the snapshots you did. We're not even sure it's the last, right? So some of the bugs might have been fixed, but this is the only thing we got.
What was the URL again? I tried.
Well, let me get out of the presentation mode here so you can see. Yeah, Yoshiki is saying don't break it. So this is a wiki. The Lively web server is a wiki. So everyone can modify this, press save, and that's what the next user sees. So use responsive. You can improve it. I'm all for it, but please don't break it. You can save it to your own. And so we actually made an update stream like Squeak had for a long time and have like 200 change sets in there, which brought the system from this state. So let me show you the work menu. That's how the work menu looked like. And there's the cool thing, there's a turtle demo in there. So, yeah. But we changed it, and now when you load the updated image, you can actually, it should work that you update from this original image. So we have a little bootstrap, which is called the base image. That's the base image, so you can at least get the load updates thing, but it takes, I don't know, an hour or so for all the change sets that we accumulated over a year. So you can fetch the updated image, and that's the most recent one. Yeah, and here you get lots of more stuff. So it's gotten
Create
bigger
a
now.
Create the stuff.
Hmm?
Create the stuff.
Create a star?
Yeah.
Create a star. Yes, stars are important. So that's something Yoshiki put in. Stars are important. And as Dan said in his talk, so this wouldn't have been possible with the machine at the time. It was just not fast enough. So we put that in. The same thing when I move a window here, it moves. It doesn't leave Scrabble behind. And actually, even these controls here, they were not there. We put that in for Elm, so you can easily move a window around. What you used to do is you press the blue button, which is, I mapped it to control left click, and you hit to say frame, and then you would have to draw a new frame, and that's where it would go. Why? Did I make it?
And then refresh the
And then
display.
screen
And then refresh it. Just play.
Yeah, it's because it didn't erase. It wasn't bothered to erase.
No, but that's
the bug.
supposed to be the new system. What? Anyway,
Yeah, that's
yeah. Okay, thank you.
Is this closed?
Before it closes, I left my hat at the pub last night under the influence of alcohol, and it's a long walk, so does anybody have a bike I could borrow?
Yeah.
Thank you.